Here you will observe the manufacture of concrete pipe. The pipe manufacturer uses automation to tie together the steel wire reinforcement. The reinforcement wire is shaped, assembled, spot welded, and cut to size by the equipment. The equipment's speed and precision allows the manufacturer to keep up with the demands of the industry. This is a quick look into how the pipe manufacturer releases the newly made pipe from the forms and prepares the forms for the next sequence. The pipes in this example, 4 18-inch round pipes, are released from the form in the upright position and left to cure. The forms, due to their size and weight, are controlled by a technician using a crane system to lift and move the forms throughout the facility. Once the newly manufactured pipe is released from the form is lowered and prepped to receive the next batch of reinforcement wire. The forms are lifted and positioned over the reinforcing cages. The forms are aligned and slowly lowered down over the reinforcing cages. If you look closely, you can see that each of the reinforcing wire cages have spacers strategically located to ensure proper spacing and concrete cover of the steel. Once the form is lowered over the reinforcement, the technician locks the base plate in place and the entire form assembly is moved to the next station. The technician lowers forms over the form liner or insert, then disconnects the form from the crane system, and the top plate is rolled out of the way. This liner will act as the form work for the inner wall of the pipe. These liners are located within a large turntable with other liners of varying sizes. The turntable rotates the forms into position to receive the dry cast concrete, which is poured into each form via an automated concrete chute and monitored by a technician. As the table rotates, the previously poured forms are rotated beneath the vibratory press head, where a technician places the press head collar over the forms. The technician, from a safe distance away, uses the vibratory press to complete the pipe. Simultaneously, the pipes from the vibratory press area are completed and rotated beneath the crane system in order to be moved. These pipes are now formed and ready to be lifted off the form liners and taken to a staging area. Once in the staging area, the remaining outer form will be removed and the pipe will be left to cure. Pipes that are produced for the Florida Department of Transportation must meet minimum acceptance test requirements. Load testing of the completed pipe occurs early in the curing process. The pipe in this video was tested at 8 days. This particular load test is a widely used method for testing reinforced concrete pipe and is based upon the ASTM standard specification C76. The testing equipment uses hydraulics to apply a load, called the D-load, along 3 bearing edges, 1 located on top of the pipe and 2 on the bottom. The 24-inch Class 3 pipe in this video has 2 D-load requirements. The pipe must not exhibit cracks of 0.01 inches and wider that are 12 inches and greater in length until after a load of 21,600 pounds has been applied. A technician operates the testing equipment while other technicians monitor the pipe for cracks. During the test, the operator communicates with the monitoring technicians by calling out the load on the pipe in 1,000-pound increments. The monitoring technicians focus on the inner top and bottom of the pipe as well as the outside of the pipe at mid-height, which during testing is where cracks will tend to initiate. Once the required test load is reached, the technician continues the test until a 0.01-inch crack width is developed. During the test, the monitoring technicians will indicate when a crack of any size appears. In this particular case, a hairline crack appears at a load of 26,000 pounds and a 0.01-inch crack width is observed at 27,000 pounds, which is recorded on the test results board. This is a close-up of the pipe's horizontal center line, also known as the spring line. The pipe has resisted forming 0.01-inch cracks in the application of the 21,600-pound D-load, and has passed the first of the 2 load test requirements per ASTM C76. The second D-load test is to check the ultimate strength of the pipe. The test is continued with an ultimate load of 32,000 pounds being gradually applied.